How are you doing? Ladies and gentlemen, thank you so much for joining me with another math lesson with Mr. Winford. Today we continue to dive into Unit 3. We have talked about multiplying fractions, dividing fractions. We talked about, well, what is a rational number? Why is fractions? Why are decimals? Why terminating, non-terminating? We talked about this terminology in the last few lessons. Now we continue on our journey in Unit 3 to begin to talk about fractions to decimals, right? This lesson should be pretty straightforward. Um, I mentioned in Unit 1, I mentioned that fractions, decimals, and percentages all are the same and they all live on this number line. Yes, they represent the rational number portion of our number line, but nonetheless, they are the same. For example, 1/2 is the equivalence of 0.5 and the equivalence of 50%, right? We will not target percentages in this lesson, but I want you to get your mind ready to understand that there's a connection, there's a similarity, as well as almost indistinguished, um, literally equivalence between percentages and decimals. Okay, so what we're going to do today is we're going to look at our worksheet, which is 3.4. If you have your packet with you, open it up to 3.4. You can join us if you need to print it out on Google Classroom. Feel free to do so. As with every lesson, we always start off with the bell work. The bell work here is asking you to classify these numbers as rational or irrational. Based on what we already talked about in the previous lesson, is A rational or irrational? Is 5, 6 rational or irrational? And is pi rational or irrational? Take a moment to see if you can tell me which classification is here. All right, awesome. I'm hoping that when you looked at this worksheet, it was pretty straightforward for you to be able to decide that 3.14 was rational. Whether you decide to try to turn this into a fraction by doing a second PRB enter, or you remember because it's a terminating decimal, it is a rational number. 5, 6 is also rational, right? If you notice, it's already written as a fraction, which should tell you right away it's rational. Remember I said to you, if any number can be written as a fraction, it's rational. In this case, it's already a fraction. And lastly, pi, which if you hit pi in your calculators, you'll see that's the equivalent of 3.1415. And continue. The numbers don't repeat, the numbers don't terminate, which lets you know that this number is considered an irrational number. Okay, if you try to turn it into a fraction, it would not work. Okay, it would not work. All right. That being the case, what I want us to do is I want us to look at the essential question quickly, look at the visualizing vocabulary before we continue on our journey. When you turn a decimal into a fraction, does the value of the number change? So when you turn a decimal into a fraction, does the value of that number change, right? When I take a fraction such as 1/2, or rather, I'm sorry, when I take a decimal such as 0.5, and I turn it into a fraction, 1/2, does that value change at all, right? If we were talking about a particular object, for example, I said to you, we have half a pie of pizza, right? Or 0.5 a pizza, right? Does it change how much pizza I have if I said 0.5 or 1/2? Does it change? No, it doesn't. We still recognize that means it's only half of the slice of pizza that exists, not the full thing. Okay, so that's why I'm trying to tell you, you need to be able to realize, okay, decimals and fractions are almost the same, just representing the number differently. Rational numbers we know are real numbers that can be expressed as fractions, and long division, which is what we're going to dive in today. I want to be able to help you guys take problems such as division problems and be able to represent these fractions as decimals using something called long division. Now, long division is a standard division algorithm suitable for suitable for dividing multi-digit numbers. Okay. Before I go into the modeling, and this lesson will be without calculators, take a moment to, if you need to pause the video and try to do A through H. Try to do A through H on your calculators, okay? I'm gonna actually pause the video here as well myself. With the next second, you won't even notice it, and I'm gonna put the answers here so that way you could see. You can see exactly what the answer is. So I'm hoping that you was able to look and get the discovery portion all done. This is what you should have got as your answers: 0.85714,286 for A, negative 3.714,28571 for B, 0.75 for C, negative 0.77 repeated for D, negative 1.4166 repeated. That's why there's a line above that 6. A negative 4.216 for F, and 0.42857143, and 0.3 repeated for H. Now notice here, I would ask you the question, are these numbers considered rational or irrational? And you should be able to say that every single one of these are rational. How do we know? Because even though some have very long decimals, they end up terminating. And that means they end up stopping. But even more so than that, you should know they were originally all fractions, right? They were all fractions originally that we turned into these decimals, right? So that's what we had. Now we used our calculator to do that, to quickly put it in. Now there's some things I would point out with B and F and E that I don't know if you picked up on it. Notice for B, the leading number here is -3, whereas the leading number there was -3. So really, you don't even have to worry about messing with the -3. Just do 5 divided by 7. Same thing with E. -1 is in the front, so I wouldn't even worry about that. Instead, I would just do 5 divided by 12. -4 is in the front. I would just do 27 divided by 125. That's how I would begin to help understand, okay, well, to turn that number into a decimal, the beginning number in the ones place, in this case, is going to be that number, -4, -3, -1. It doesn't have to be a negative. It can always be a positive as well. But just so you know, when you're turning mixed numbers into decimals, remember the leading number in that mixed number should be the ones column, okay? Whereas the rest of the stuff is going to end up creating your tens and hundreds and thousands place. Now, I want to show you how to do this without the use of a calculator. Now, when I say without the use of a calculator, I'm really saying I want you to show all the work. I want you to show me your work. Could you use the calculator to be able to make sure you got your answer correct? Sure. Could you use a calculator if you don't know certain division things? Absolutely. All right, I'll go through a couple examples with you, A and B, so you can get an understanding of what I'm expecting you to do throughout this worksheet. We are going to use long division. It's something that maybe you remember in the past using, but we're going to do it where it's going to give us these decimal answers, give us these rational numbers. Okay, you know they're rational because we're taking fractions and turning them into decimals, so that means they must be rational numbers. All right, to start us off with, take a minute, and I'm not going to say it out loud, but you do it. Do 1 divided by 125 on your calculator, okay? 1 divided by 125 on your calculator. Now, you should be able to get that answer. You should see the answer. Boom, it's there, okay? I'm not going to say anything about it. I don't know what it is. I don't have my calculator in front of me, but I do want to be able to say, okay, great. Now that you know what the answer is, that's the route that you need to go to make sure you do that. We're going to use long division to get there. Now, when you use long division, I need you to know some things, okay? Something very important here, okay? Dividend, divisor, quotient, right? When we think about long division, there's 3 components here that you need to hold on to and memorize and know. You need to know, not only that, you need to also know where they go in terms of place. Give me 1 second. I just want to do something quickly. What I want to show you is I want to show you a visual quickly of where these 3 represent. And I know there's a lot going on here, but if you just zoom into this picture right here, right? This picture here, maybe I can visit the website. We can see it together. It pops up, but the visual is here, but it's not showing up. Okay, let's go back here. Notice here, there are 3 things you need to know when it comes to dividing. There's a dividend, there's a divisor, and there's also a quotient. Quotient is the answer. We know that always goes on top, but then there's a dividend and divisor. And normally the dividend, when we look at fractions, is always the numerator, okay? The dividend is the numerator, whereas the divisor is the denominator. And I'm gonna write that on our worksheet in a second, but I just wanted to show you this visual, okay? Now, I want you to also notice that this house, or this dividing symbol, is very similar to our square root. And I know I haven't gone over square root yet. It's coming up in this unit, but we have seen a little brief moments of it in terms of classifying numbers, but this is representing division here. It's not the square root symbol, okay? So when I do it, I'm not gonna make it I'm not gonna make this curve. I'm just gonna go straight down and over, okay? So let's go back to our worksheet, okay, where I can show you what we're looking at and how to recognize what's the dividend, what's the divisor in this situation. So first of all, for you guys at home and on your papers, I would want you to write, this numerator here is going to represent your dividend. Okay. In other words, you can say inside. You can say inside, because that's what it's going to be. It's going to be inside the house. Whereas this right here is a divisor. This is outside. Now, of course, I'm not going to test you on that. That's not what I'm testing you on. But I do want you to know that. So when I set this up to do long division, it's going to look something like this. And some people think it's going to be 125 on the inside. It's not. It's going to be 125 on the outside. Okay. This nice little house thing, right? And I'm going to put my 1 here. Okay. I'm going to put 1 there. Now, what I'm going to do is I'm actually just going to bring this down a little bit because I know, okay, I need to put my quotient up there and I want the space to be able to put the quotient. Right now, so I start off when you write it. This is how you start it off. You write it like this, and you remember you're going to ask yourself, how many times does the outside number go in the inside number? Right now, this seems a little weird. How many times does 125 go into 1? That doesn't make any sense. It cannot happen. Right? You're looking for multiples. You're looking for division. You're looking for something that makes sense. Right? 125 does not go into 1, so that's going to be a 0 at the top. I'm going to put that in red. 0. So once you do that, then you say, okay, well, that didn't work out. Let me add another 0. And before you add a 0, I want you to understand something. Since there wasn't a 0 here, we put a decimal point. Let me say that again. There wasn't originally a 0 here. We just put that 0, which means that that number was done. So we need to put a decimal showing us that this number is all done. Okay, so we put a decimal there. You put a decimal also at the top. And now you ask yourself once again, this is 125 going to 10? The answer is no. I add another 0. Does 125 going to 100? The answer is no. Okay, we add 1 more 0 and 125. Does it go into 1,000? Now it has to. There's no way it can't. Obviously, sometimes what you're going to get is you're going to get, let's say it was 6. Okay, but this number, it may not be 1,000. You write it down, you subtract, and you keep going. Okay, because I'll do A, B, and I'll also do another one on the next page as well, because I want to make sure I really show you a good example where sometimes you'll have to keep going. Okay. Yes, does it? How many times does it go into 1,000? Now it does. What I'm going to do on my calculator is actually I'm going to take my calculator out, and I know you're like, well, Mr. You said no calculators in this section. Without calculators. What I want to do here is ask myself, well, 1,000 divided by 125. If you want, you could do 125 times 2, 125 times 3. You can list out the 125 times table. In this case, I'm just going to do 1,000, and I'm going to write my notes over here so you can see exactly what I'm doing. In my calculator, I'm typing in 1,000 divided by 125, and I want to see what it gives me. Now, when that answer, it actually gives me 8, which means that if I multiply 8 times 125, I get 1,000. I'm going to put 8 up here. And I'm going to subtract. 1,000 minus 1,000 gives me 0. Now you're probably like, well, Ms. River, didn't you put a decimal there? I get it. The decimals really let you know that the real number we're dealing with stops here. And that decimal lets you know that the decimal should actually be carried over up here. But we can consider this number 1,000. 1,000 minus 1,000 ends up giving us 0. This tells us something very special. This means there are no remainders. Okay, no remainders. Now, why does it matter if there's no remainders? Because these are called rational numbers. They're not irrational. The rational will keep going. The decimal will keep going. When you get no remainder, that tells you that this is a terminating decimal. It stops. That means that our answer is here. Okay, so our answer for this particular problem is 0.008. All right, now you guys already looked it up when you're on your calculators prior to me doing it. Did it give you 0.008? Yes, it did. Now, if you just write the answer, but you don't show me this work, it won't count as credit, because the goal here is to show me you can do long division. Okay, let me go into B. Now, B is a mixed number. Similar to what I said when we looked at B, E, and F above, you should know that when I go to solve this, my answer is going to be -2 point something. I don't have to deal with turning this mixed number into improper fraction. Don't do that. We're just turning them into decimals. Our goal today is to turn these fractions into decimals. And the way we're going to do that is if we already have a mixed number, bring that -2 down. The mixed number portion, that whole version, that whole number, bring that down. Bring that integer down, -2 point. Okay. Now I got to figure out what is 3 divided by 5. Once again, 3 is going to be inside the house. 5 is going to be on the outside. Okay. Now, once again, I'm just going to drop mine just a little bit because I want to make sure I have the space to put the quotient above it. Okay. I asked myself, how many times does 5 go into 3? The answer is 0. I know this number stops here, so I need to make sure I add a decimal there. I'm going to add another 0. How many times does 5, and I apologize, that is a 5. How many times does 5 go into 30 now? Right, if you know your 5 times table, you know 5, 10, 15, 20, 25, 30. It does exist, and that's at the number 6. So I'm going to put 30 here because 6 times 5 does give me 30. And we're always subtracting. If you have that question right now, you're probably like, Mr. Woodford, do we always have to subtract? Yes, we're always subtracting. We're always subtracting what we got to multiply. Now, in this case here, it ends up giving me 0. What does that mean? That means there's a remainder of 0. That means there is no remainder. That means it's a terminating decimal. That gives us our answer. Now, our answer is actually that -2. It's going to be -2.06. My apologies. Okay. So we're going to, not 0.06, just 0.6. I apologize. I'm looking at it, trying to make sure I write it correctly. Notice this one place value, and I want to point this out. This is the ones place. This is the ones place. We already have a number in the ones place. So all we need to do is put the tens place there, which is 0.6. So this is our answer right here. Okay. Questions. If you have a question, make sure you add it onto Google Classroom. I'm looking forward to it. Before we close out, I do want to do one more. I said I would do one more with you. Turn the page with me. Let's look at the independent practice, because sometimes it doesn't work as neat as this. Sometimes you have to keep going. Sometimes it's a lot of work in order to get to that terminating decimal. So I do want to do one more with you. Okay. Let's look at number 5. Why not? Okay, let's look at number 5. I'll do number 5 with you. I'm gonna set it up. It's gonna look something like this. Okay. How many times does 11 go into 6? That answer we know is 0. I'm gonna add my decimal. Add another 0 there. How many times will 11 go into 60? Now that answer is actually 5. 55. Okay, 5 times 11 gives us 55. Notice this is not going to be as smooth. There's another 5 here. I drop it. How many times does, now that I did this and I dropped the answer here, I asked myself how many times 11 goes into 5? How many times 11 goes into 5? Right? That answer we know it doesn't exist. But however, what we do now is we make sure we grab another 0 here. We drop it down here. We drop it down here. Okay. And what I'm going to do here, because what I'll recommend you guys do beforehand is if you need to check it to check to make sure you're on the right track, you could divide it and show it, see what it looks like in a calculator. For example, here I said, okay, well, I did no for 6, 60 was 5, 55, drop a 5, add a 0, bring that 0 down. All right, now these zeros are called placeholders. Put a 0, bring it down. How many times does 11 go into 50? That answer is 4. So I know that that's going to be 44. Subtract. My answer here gives me 6. Okay. I'm going to drop another 0 down. Oh, my apologies. And I'm going to ask myself, how many times does 11 go into 60? Hold on. That seems a little weird. This is 60. Isn't this up here? Wasn't this 60? Okay, I'll keep going. 55. I know that's 55. But then I get 5. So that means this was 5. Add a 0. and it gives me 50 again. Hold on, that gave me 50 before. Do you notice something that's happening? This is called a pattern. So what does this tell you? Because when I put this answer up here, it's going to be a 4. That tells you there's a repeating decimal happening. So what is my answer? 0.54 with the line above it. Because what I'm going to end up doing is keep repeating it, right? That's how you pay attention. Pay attention as you do it. Now, some of them is going to take a lot longer. Someone's going to maybe be 4 digits until it terminates. Take your time, do the multiplication right, keep going through. If there are any questions, feel free to ask me them, and I would love to answer them for you, okay? I know this video is a little bit longer than usual, but I know as a recap video, some of you guys might be strong in it, some of you guys might be weak in it. But nonetheless, thank you so much for joining me for another math lesson with Mr. Woodford. Until next time, I'll see you then.